Hello lovelies, in this video the brilliant Charlotte is going to be working you through our Edexcel A-Level Maths paper 3, our predicted paper for 2023. Now, she is so good at telling you exactly the sort of things you need to pick up in the question. So any clues that the examiner is giving you, and then she's going to show you detailed working out. So if you've already looked at mark screen and you can't quite work out how that fits in, then this is the perfect thing for you. There are loads and loads of examples in here that you could apply to the real exam. So grab a pen and grab a paper and let's get started.
Alright, so in this question here, we are told that in a survey, we found that out of 1,250 households, 888 homegrown fruit and vegetables. And then they ask us to use the binomial distribution to find the probability that out of a random sample of 20 households, exactly 18 eat homegrown fruit and vegetables. So for a binomial distribution, we know that it takes the form that the distribution has n and p as its variables. Now, in this case, n is going to be 20 because that's how many households we're looking at in this sample. But the probability we need to work out, and the probability of people eating homegrown fruit and veg, we can work out using the data at the beginning of the question. We know that 880 people out of 1,250 ate homegrown fruit and vegetables. So if we tap that away into our calculator, we'll get 0.704. And that there we can use now in our distribution. So we can say that x is a binomial distribution where n is 20 and the probability is 0.704. So now that we have that, we can say that we are looking for the probability that x is equal to 18. And now we can go to looking at how we would enter this into the calculator. So I use an FXCG50, but the same principle should apply whatever type of calculator you use. So let's have a look at how I use this. So first I would go into statistics mode, and then I would go to distribution, and we want here the binomial distribution. And because we want when it's equal to 18, we use BPD, binomial probability function. So x is going to, in this case, be 18 because that's specifically what we're looking for. We have 20 trials and the probability is equal to 0.704. So we want to execute that and then it will give us our probability, which as you can see here is equal to 0.0300. And that would be it there to 4 decimal places. So that would be our solution for this first part of this question. So then for part B, they say give a reason why you wouldn't expect your calculation to be valid for 20 households on a specific road in the village. So what this question here is really testing you on is when is a binomial distribution valid? And it is valid when we have a constant probability of a success or a failure event happening. And also we need it to be independent. And the thing is if we're looking at a single road on this village, you can't say that these houses are all independent because it is likely that, for instance, if they all have large gardens, they will all have large gardens on that road, or no garden at all. You know, different roads, all those houses are normally built consistently with each other. So here we would say that it is not independent. So the binomial distribution is not suitable. Perfect. So that is good. So if you're at all unsure on any of your rules for when you can use certain distributions, that is certainly worth making a little flashcard of, because a question like this just relies on you knowing when you can use certain distributions. And this one about independence being a blocker comes up a lot. Okay, so great work. Let's try the next question then. So in this question here, what we have is a few facts about a train and the probability that it is late. So we're told that the probability that it is late on any given day is 0.05. And then we're said that the number of days on which the train is late during a 365-day period is denoted by the random variable y. And then we're asked to find a value of a, so that's the probability that y is bigger than a is about 1/10. Now, with this particular question here, we need to first work out the distribution. And initially here, you could think binomial because, of course, we know n, don't we? We know that n is 365 and we know that the probability is 0.05. So here, because that number n is so large, we can instead use the normal approximation. So the standard form for this normal approximation is that the y distribution for n is np and then npq. So what that tells us then is that np is our mu and our npq is sigma squared, or the variance. So we could say that mu in this case is np and sigma, the standard deviation, is the root of npq. Now I'm saying npq here. What is n, what is p, and what is q? So n we have already said is equal to 365 and p is 0.05 and q therefore is 1 minus p. So in this case that would be 0.95. So we can put those numbers in to work out what those values are. So in this case mu would be equal to 365 times 0.05. I'm tapping that into the calculator, I get 18.25, whereas for sigma squared I get 365 times 0.05 times by 0.95. So for sigma squared I get 17.3375. So those are our really important values there. So we know what mu is now and we know what the variance is. So now to work out the probability that y is greater than a is about 1/10, what we want to do is to use our calculator, and we want to use the inverse normal distribution in this case, because in this case we're given the probability and we want to go backwards and work out at what variable we get a probability equal to 1/10. So I will show you here what I did using my calculator to work this out. So I had my calculator, I put it into statistics mode, and I went to distribution. And in this case, the way that we've laid it out, we want the normal distribution. So I selected normal. And in this case here, we want the inverse. Okay, and because we're looking at bigger than a, we want the bit which lies to the right. So imagine we want bigger than a, so that's the bit to the right, isn't it? So therefore, for the area, don't forget the area is actually the probability. So the area there is that 0.1 or 1/10. Now the standard deviation is equal to the root of 17.3375. So that's what I'm going to type in here, root of 17.3375. And then for the mean, I'm just going to enter 18.25. So now that I've selected all of that, I select execute, and then for the inverse, I get a solution. So that in this case is what A is. A is equal to 23.586. So because we're looking at a value for A, an actual discrete number rather than just a decimal, and we're looking at where it's about 1/10, it's not like bigger than 1/10 or less than 1/10. We can either say here 23 or 24, because the A, the actual A, the exact value that is going to give us that exact probability is 23.586, but we're just looking at around 1/10 and we want a discrete number, so that would be that one there. Good. All right then, so let's have a look at part B then. So this question here, I think, is really quite challenging. So if you tried this and just couldn't figure it out, you are not alone, because I think very few people will be able to get this in full correctly, okay? So having a look at this, we're looking at the expansion, which is 4. You can see here 0.05 plus 0.95 to the 50. And we're looking at the terms involving 0.05 to the r and 0.05 r plus 1 are denoted by tr and tr plus 1 respectively. So what we're being asked to find here is the term which is 0.05 to the power of r. Now, first thing we need to do here is let's just write down the generalised expression for a binomial expansion. Okay, so for this formula, we know that the probability of an event happening in a binomial distribution is equal to n factorial over x factorial times by n minus x factorial times by the probability to the power of x of, say, one of the events. So this could be probability of success of one of the trials, so in this case the train being late, times by q to the power of n minus x, which in this case would be the probability of the train being on time, let's say. Now, because this is a binomial distribution, we know that there's only two possibilities, and that is why a binomial expansion can still work and help us with this. So I guess here we need to relate this to what we have in this case. So we would say then that p is equal to 0.05 and q is equal to 0.95. And we're being asked to find here a term involving 0.5 to the r. Now that's a bit like saying find the squared term in a binomial expansion. So in this case then, we're looking at when x in our expansion is equal to r. So we know that n is equal to 50. So what we can do to find that TR, which is going to involve the term which has 0.05 to the R, to do that, we can just make a substitution now. So that is going to be 50 factorial over R factorial times by 50 minus R factorial times by 0.05 to the R times by 0.95 to the 50 minus r. So that is what TR is, and we want to divide that by TR plus 1. And thinking about this all the same again, so if we think of what we said was true for TR, if we want a term that has r plus 1 in it, to the power of r plus 1, then in this case we will want to adjust our x to r plus 1. So we're going to do the same thing now. I'm going to write this all together so that we can straight away work it out. So in this case, it's going to be over 50 factorial over r plus 1 factorial times by 50 minus r plus 1 factorial. And then that is times by 0.05 to the r plus 1 times by 0.95 to the power of 50 minus r plus 1. So, holy moly, that's a lot going on there, isn't there? So we can cancel this down now, okay? It may not feel like it at first, but we can, all right? So first things first, and I suppose the easiest thing to look at would be these guys here. We've got 0.05 to the r over 0.05 to the r plus 1. Now, that could be equivalent as, say, x squared over x cubed or something. You know, if we think about that, that's x2 over x2 plus 1. Now, I know that that's different, but it's the same structure of it's a power over the power plus 1, all right? So when we do cancel that out, what we end up getting is just one of them left on the bottom. So here, what that particular bit is going to cancel down to is just going to be a 0.05 on the bottom. And the same is going to apply with the rest as well. So we've got 50 minus r, but then on the bottom we've got 50 minus r plus 1. Now in this case it's kind of the other way around, I suppose you could think of it as, because the bigger number, by the time we've subtracted from that 50 on the bottom there, the r plus 1, we're going to end up with only, say, 49 minus r, aren't we? Which is a smaller number. So actually here, whereas we had just mentioned like a little example just to try and give it a bit of context with numbers before, if we did the same thing here and imagine we've got, say, 0.95 to the 50, and just ignore the r for a moment, over 0.95 to the 49, when we cancel those down, we're going to see that we just get left with the 0.95 on the top. And that minus r isn't going to make any difference because that is just going to reduce both the top and the bottom by the same amount. All right, so in this case here, we're going to cancel these out and we're going to be left with the 0.95 on the top there, okay? Some hard maths going on here, I think. So now what we want to do is to look at the next bit. Okay, so here straight away, there's a 50 factorial in both formats on the top and the bottom. So I'm going to cancel out that 50 factorial. So now though, we have got this r factorial and r plus 1 factorial. And also we've got the fact that these fractions are a bit weird. Essentially what we've got here, when we've done that cancellation, is we have now got 1 over r factorial 50 minus r factorial. And of course I'm isolating all of this. I'm now only thinking about this little section here. Even if for a second here I forget that I cancelled out that 50 factorial on the top, and imagine we keep it there. I will show you how we can see that that has cancelled out. So just thinking about that little highlighted blue bit, I've got 50 factorial divided by r factorial times 50 minus r factorial, and then that is divided by 50 factorial over r plus 1 factorial, 50 minus r plus 1 factorial. Now, when we divide fractions, we do the KFC rule. We keep the first one the same, we flip the second one, and we change the sign to a multiply. So we're going to do that here. So that gives us times r plus 1 factorial, 50 minus r plus 1 factorial, and then over 50 factorial. And this is where you can see that the 50 factorials will cancel. But we should get a bit more cancelling here as well. So here, because of these factorials again, we need to think, how can we cancel these? Now, I'm going to take as an example of the r plus 1 factorial and the r factorial. If we imagined that we had, like, r was 5, say, and we had 5 factorial on the bottom, and therefore r plus 1 would be 6 factorial. If we had that, then we know that 6 factorial is the same as 6 times 5 times 4 times 3 times 2 times 1. And on the bottom there, 5 factorial is 5 times 4 times 3 times 2 times 1. So the point being is all of these can cancel out except that initial n plus 1 or r plus 1, the 6. So in this case here, we're going to get the same thing happening. So the whole r factorial on the bottom is going to cancel, and everything except the r plus 1 will cancel on the top there. So we're going to get a similar thing happening with a 50 minus r plus 1 factorial divided by 50 minus r factorial, except in this case, because you've got a subtracting of a bigger number on the top there, the bigger of the two is actually the denominator. So when they cancel, it's actually the 50 minus r plus 1 factorial that cancels entirely, and then that leaves us with just the 50 minus r on the bottom. So I'm going to delete a good chunk of all that working now, and we're going to put this together. So we have said tr over tr plus 1 is going to simplify 2. And for what we just said, from what we just worked out from cancelling these horrible factorials, we get left with r plus 1 over 50 minus r. And then that will be multiplied by the 0.95 that we had a cancellation to make over here, over the 0.05 that we got down here when we cancelled those pink bits. So tapping that into your calculator, the 0.95 over 0.05, we get left then with 19 r plus 1 over 50 minus r. And that is what they wanted. So honestly, I think that really takes an advanced level of math. And I think for 3 marks, that's very, very challenging. And the thing is, the main thing to remember when we face a question like this, you don't need 100% to get an A star. So if you've seen this question and it is very, very, very confusing, don't freak out about it. Just listen to what I've just said, try and take it in, try and sort of inhale that vibe of understanding. And if it's still slightly confusing, well, at least now you've got some tools that you can potentially use. But I wouldn't stress yourself out about it. It just isn't worth it. But let's try the next question then. Okay, so part C now. This is going to use a lot of what we have just done. So we have found out, well, it was a show that, so we know it anyway from part B, that ratio of TR over TR plus 1 is equal to 19 r plus 1 over 50 minus r, okay? So that's something that we got from previously. And we're told to find the values of r for which the probability that x is equal to r is bigger than or equal to the probability that x is equal to r plus 1. Now, the thing to remember here is when we picked apart that binomial expansion, essentially that tr was giving us the probability when x is equal to r, and that tr plus 1 was actually giving us the probability when x was equal to r plus 1. So if we take what they've given us here and we try and rearrange it so that it looks in that same structure, so we've got that ratio, that fraction, if I divide both sides here by the probability that x is equal to r plus 1, what I will then be left with is the probability that x is equal to r over the probability that x is equal to r plus 1, which is less than or equal to 1. And we've just said that this ratio is the same as this ratio. So that means we can replace that with 19 r plus 1 over 50 minus r. And so that is what is now less than or equal to 1. And so that means that we can rearrange that to solve it for r. So let's give that a go then. So I'm going to multiply out the brackets. That's 19r plus 19. And then I'm going to multiply through by that 50 minus r, the denominator. And then get all my r's together on one side. So there I get 20r is less than or equal to 31. And so r therefore is less than or equal to 31 over 20. So if I tap that into a calculator to get an actual numerical value for it, that gives me that r is less than or equal to 1.55. But we need it to be an integer, so we would say then that r is less than or equal to 1, because it could never be 2, so we need to round down there. Okay, so that's really good. So let's see D. So hence find the most likely number of days on which the train will be late during a 50-day period. So this is still all talking about the same thing, all right? So we will then be able to use the same data. We are looking at a question that says hence. And whenever we say hence, that means we need to directly use what came before. So we've already narrowed down these number of days to either being r is equal to 1 or r equals 0, because of course we know that r has to be less than or equal to 1. So if we then put into the ratio that we have, this tr over tr plus 1, if we substitute in our values, we should see which one gives us the biggest value. So if we put r as 1 in, then we get 19 times by 1 plus 1. All over 50 minus 1, which if I tap that into the calculator, I get 0.7755, which is indeed less than or equal to 1. That's good. If we were to also use 0, so that would be 19, 0 plus 1 over 50 minus 0. What I get then is a smaller number. So we would stick with the biggest of those numbers, and therefore we get 0.7755. which relates to 1 day. Perfect, so a very challenging question, that one, but I think it's critical that you remember here that you don't need 100% to get an A star. And also, these questions C and D, they are accessible even if you couldn't do B, which was only a 3-mark question. It's not that big a deal because B was a show that. And whenever you are in A-level maths and you have some show that's, really remember that that is your opportunity to still do the rest of the question. You do not at all need to stop there. Well done for getting through that. And let's try the next question now. Okay, so for this first question here, you can see that we have a normal distribution, and it says that in the question. So it tells us a couple of facts which enable us to write the normal distribution for this particular question. So we know that the mean is 24, and we know that the standard deviation is 6. Okay, so we know that the mu is 24, and we know that sigma is equal to 6. So here where they say find the probability that a randomly selected battery will last longer than 22 hours, we can use our nice calculator to help us with this. And I'm using my specific calculator, but of course the same idea will apply whatever calculator you have, so it's still helpful even if you don't have the same calculator. So what I would do here is I would go to the statistics mode, distribution, and then normal distribution. And in this case here, we want the cumulative distribution, so the NCD. So for the lower bound in this case, I'm going to put 22. And for the upper bound, because it's a normal distribution, I just want us to do just a big number, because that's all really that it is referring to. This is essentially what we're trying to find here, this shaded region here. So the standard deviation we have said is equal to 6, and the mean is that middle value for normal distribution, which is 24. So entering that all in, and we get a probability there. You can see that they tell us that P is equal to 0.63055,866. So if we give that a rounding to say 4 significant figures, we get 0.6306, and that there is our answer to that one. So this next question here is a bit of a trickier one. We really need to put a bit of thought into it. Okay, so we're told 4 new batteries were put in the game console and it was used for 18 hours over the next week. Find the probability that it will continue to work for an entire 3 hours play session. So we've reached the end of that week then, and we want to play with our computer console. So we want to play for 3 hours straight. So to work this out, we need to know what is the probability that the length of time, the lifetime of these batteries will be bigger than 21, because that is essentially the 18 that's already existed plus another 3, given that it has already worked for 18 hours. So to work that out as a probability, we need to know the probability of the lifetime being bigger than 21 over the probability that the lifetime is bigger than 18. So once we do that, that's going to apply to one battery. So we need to work this out for just one of them first, and then we will apply that to the rest, all right? So first things first, let's work it out, the probability that L is bigger than 21. And we're going to use our calculator in the exact same way that we did before. For the lower bound, we will state 21 this time. For the upper bound, just type in a big number. And then for the standard deviation, you will again use 6. And the mean will still be 24. And you will type those all in, and then you will end up getting a value for your probability. So for the probability that L is bigger than 21, I make it 0.691. And then we'll do the same for the probability that L is bigger than 18. Again, the same values, it's just the lower bound will this time be 18 instead. Upper bound, I would still just use a big number. And for the standard deviation, it's still 6, and the mean is still 24. So putting those all in, I get the probability that the lifetime is greater than 18 is going to be 0.841. So tapping those into my calculator to get an actual value for this, I get that the probability that the lifetime is bigger than 21, given that the lifetime is bigger than 18, is equal to 0.82164. And the reason why I haven't rounded that yet is because we then need to finish it off. And we don't just have one battery, we need to rely on all 4 of these batteries staying in working order to end this gaming session. So we need the probability of success times probability of success times probability of success times probability of success, which is the same as 0.82164 to the power of 4. So that gives us 0.45575. And that there will be our solution. If we wanted to round that to 4 decimal places or 4 significant figures, would end up being equal to, I would end up rounding to 0.4558. Perfect, so that was really good. All right, so let's have a look at part C. Okay, so for part C here, instead of playing right away after 18 hours, the games console has 2 batteries replaced at random. Show that the probability that the games console will not stop working is 0.675 to 3 significant figures. Okay, so in this case here, what we need to do is we basically need to do the probability that the lifetime is bigger than 3, and that has to happen twice in a row. So remember, we have 4 batteries here, so we're relying on 2 of them lasting for more than those 3 hours. They're the batteries that we replace, so they don't need to last quite as long a time this time, do they? Because of course, we're just looking at the probability of their lifetime exceeding 3 hours this time. So because, again, like the binomial thing that we talked about before, because we're looking at this happening twice in a row, we need that probability to happen once and then twice. So we will square that probability. And then we will, instead of, because in the last case we did it to the power of 4 because it was the same probability each time. That's not the case now. So it's going to be the probability of the lifetime lasting more than 3 hours squared, because that is the 2 new batteries. Then there's still going to be 2 old batteries. And we just worked out, didn't we, the probability of them exceeding this after they've already had that busy week gaming and now they want to have another big long game. You know, we've worked out that probability. So this is going to be from the value that we worked out previously for that. So if we wanted to work out the probability of the lifetime exceeding 3 hours, we would just go to our calculator, and you can see here that we just go to statistics mode, we go to distribution, normal, we want the NCD, so the normal cumulative function, and then we will just replace for the lower bound 3, the upper bound again, we'll just do a big number. We've still got the same standard deviation and the same mean. So this, you can see, is a number which is certainly close enough to 1. If we were to round this to any real order, like 5 significant figures, 6 significant figures even, it ends up rounding simply to 1. And So 1 is for that first bit, 1 squared, and then we times it by the 0.82164 that we found out as a part of part B. That gives us our calculation. And then so finally, if we tap that into a calculator and we round our answer to 3 significant figures, I get 0.675. And that is what they wanted for this question. So that is our completed answer. Okay, so last bit of the question here. We want to work out a hypothesis test now. We have a random sample of 25 batteries and we find that the mean lifetime was actually 25.5 hours. So here we want to do a hypothesis test for the mean lifetime. So to do this, I would start by writing down my hypotheses, and this will get us our first mark. So the null hypothesis, we know that the mean would be equal to 24, and that is just, we're still in the same scenario as before, okay? So the same as part A and part B, the mean is equal to 24. And our alternative hypothesis, because we're looking at the lifetime actually being a number higher than that 24, we're going to say that our alternative hypothesis is that the mean is bigger than 24. Okay, so that is our null and our alternate hypothesis. So in this case here, because we're looking at the means and the distribution of the means and assessing that, we need to use a new kind of distribution, one which looks like the distribution of the means is normally distributed, with mu being the mean, and then instead of writing just the standard deviation, it's the standard deviation over n. So the standard deviation is still 6, the mean is still 24, but when we put this in now, we will get 24, and then it's going to be basically 6 squared over 25. Now don't forget that this bit here, that is of course equivalent to sort of sigma squared, so when we want to enter that into the calculator, we're not going to put, say, sigma in, this for the standard deviation, we're going to just put 6 in. We're going to put 6 over 5, which is essentially the square root of that. So if we did the square root of 6 squared over 25, we get left with 6 over 5, so 1.2. Okay, so that would be our standard deviation. Our mean will be 24, and one thing that we have to be careful of here is just to do, we're looking for the probability where x is bigger than 25.5, and we're going to put in to our calculator, we're going to go to the normal distribution again, we're going to go to the cumulative normal distribution, and for our lower bound we will state that 25.5. For the upper bound we will just do a really big number again, and then for the standard deviation in this particular place we're going to put 1.2, and for the mean we're going to put 24. Okay, so with that, tapping away into the calculator, I get my probability to be equal to 0.10564977. So because here we're being asked to use that at the 5% significance level, we can see that this probability we just found is actually bigger than 0.05. So what we will say then is that there is not significant evidence to support the longer battery life. So therefore we are going to just accept the null hypothesis. Perfect. So I hope that made sense, and let's have a look at the next question. All right, so this question here is all about finding the mean and standard deviation of a few students' expenditure of food and drink. So let's have a look at this then. So we're told a few bits of data here. Firstly, we're told that we have 100 students. Now that's going to be a very important piece of data because we know what our N is in this case. We're told the maximum amount recorded, the minimum amount recorded, and we are also told what the sum of our x's are, and also the sum of x minus the mean squared is. Now the reason why these are so important is that imagine if we actually were given the raw data of 100 students. That would be so many. We wouldn't have a chance. It would just be a data entry exam, wouldn't it? So instead they've given us some information which summarises it that we can use using the formulas that are in the formula booklet to help us calculate this. So we won't need for part A the use of any special calculator functions to work this out. But let's have a look here then. So to find the mean, what we do is use our classic equation that we've been using for a long time now. We would say that the mean is equal to the sum of x divided by n. So in this particular case, that means that the mean will be 3,742 divided by 100. And that leaves us there with 37.42. And that is our mean. So the mean, we can make a note, is equal to 37.42. So the standard deviation, we do have a formula that can help us work this out. So the standard deviation is the square root of the sum of x minus the mean all squared and then divided by n. So in this particular case then, we've been given the sum of x minus the mean squared, so we can just substitute that in again. So it is the square root of 2,657.61 all divided by 100, and that's all square rooted there. And then we'll tap that away into our calculator, and then to 2 decimal places I end up getting 5.16. So the standard deviation is equal to 5.16 if we round it to 2 decimal places. Okay, so now we're asked to explain why the normal distribution can be used to model x. So we were given some information about the maximum amount recorded and the minimum amount recorded. So when we have a normal distribution, we know that nearly all the data lies within 3 standard deviations of the mean. So that's an important thing to know. So for normal distribution, nearly all data lies within 3 standard deviations of the mean, okay? So therefore, what we can do is we can use the data that we've just worked out. We know what the mean is because we just worked that out. And we know what the standard deviation is. So if we do the mean plus 3 standard deviations and see what we get, I will tap that away into my calculator and I get 52.96. So then if I did the same and I did the mean and then I took away 3 standard deviations, I end up getting £21.88. Now if we go back now and we compare that maximum value to the maximum value that they mentioned earlier, you can see they are really, really close. And so for the minimum one, let's have a look at that as well. Again, really, really close. So we could say then that these are very close to the minimum and maximum values. And then the fact paired with that normal distribution, having nearly all the data lying within 3 standard deviations of the mean, we can therefore say that that is a good result because they are very close to the maximum and minimum values. Okay, so looking at part C now, we're asked to find the probability that a student spends less than £30 on food and drink per person per week. So what they're asking us to do here is find the probability that x, if that is the distribution we're talking about there, that x is less than 30. And we know, don't we, that the mean is equal to 37.42. And we know that the standard deviation is 5.16 if we round it to 2 decimal places. And we also know it is a normal distribution as well. Okay, so we know that we have a normal distribution where the mean is 37.42 and the standard deviation is 5.16. So there then, what we can do is we can use our calculator. So now let's have a look at what I did to work out this solution. So I use a CG50, but the same will apply to others. So we go to the distribution section and then normal distribution. In this particular case, we want NCD, so the cumulative distribution function. So for the lower bound here, I'm going to put in 0 because we are looking at the smaller end between 0 and 30. Then for our standard deviation, we know, don't we, that that is 5.16. So we will put that in as well. And then now we will put the mean in. So for the mean, you can see that that's 37.42. So you'll enter that, execute it, and then you can see there that we get a probability equal to, and this will be our solution. You can see up there on the top, I'll highlight it for you. We've got the probability is equal to 0.075. You could write 22 if you were doing it to like 4 significant figures. They haven't said how many significant figures to round it to. It never hurts to do it to a good chunk. So that there is our solution, and that is how we would do it. So like I say, other calculators all will use that same principle, but let's have a look then at the next part to this question. So this question here follows on from the previous scenario. But now we're looking at a different sample of students. So they tell us that the weekly expenditure is Y pounds per person on food and drink, and it can be modelled by a normal distribution with a mean of 42.68. So we've got a new normal distribution now, and we're talking about it being in terms of Y. So let's write the distribution out. So we've got the normal distribution, the mean is 42.68, the standard deviation is sigma, so we'll add that in there. That is our normal distribution. So the problem with this is we know what the mean is, we know it's 42.68, but we don't actually know what the standard deviation is. That is our unknown there. Now they tell us that the probability when y is less than 45 is equal to 0.74. So what we're going to have to do here to work this out is to use the inverse normal distribution to do this. And our calculators will help us do this again. Now, the issue is we need to have values for the mean and the standard deviation to enter into our calculation, even when we're doing the inverse normal distribution. That means that we want to do like a little bit of a change up to be able to normalize this, okay? So we essentially want to rewrite this, and we could do it in terms of z, just to change it up. We could say that z is equal to that y minus the mean over the sigma, and that is equal to that 0.74. So we know in terms of the y distribution that y is less than 45, the probability of that is equal to 0.74. But we need to use a new distribution now. We need to use a distribution whereby the mean is equal to 0 and the standard deviation is equal to 1. Okay, so that's going to be important because when we're in a minute going to put this into our calculator, we're going to keep mean this time is going to be 0 and sigma is going to be 1, and the probability we're actually going to know is equal to 0.74, and we want to use the inverse normal distribution because that will essentially give us what this whole region here is equal to. So in this case, the y will be 45 as well. So here in this case, what I would do is I would say that the probability that z is less than z is equal to 0.74. Let's do this to get a value for your z, and then that is equivalent to this y minus the mean. Okay, so let's have a look now at what I did on the calculator to work this out. Okay, so I went to the statistics mode, I went to distribution, then normal, and this time we want the inverse normal. So here then, I want us to have the left-hand tail in this case. The area is that probability, okay? So whenever we say area, that is our probability. And then the standard deviation, we know that in this case here, because we've standardized this, it is going to be equal to 1, okay? So we're going to put 1 into the calculator now in place of the standard deviation, and then for the mean we'll put 0. And we'll press execute, and that value there that we get is what that z value is equal to. So that there is equal to 0.64334454. And in that particular case then, we can equate that to that y minus mu over sigma. And we're not done there because we know what the mean is and we know what y is, don't we? So we can now put these in and then rearrange it to find what sigma is, what the standard deviation is. Okay, so putting all that together, so y was 45 minus the mean, which we said was 42.68. And that's all over the standard deviation. And we know from using the inverse normal that gives us 0.64334454. So rearranging this to get sigma on its own, I make that 45 minus 42.68 all over 0.64334454. So if I tap that away into the calculator, I get a value for sigma equal to 3.6. if I round it to one decimal place as they want in this question. And then there you go, that is it done. So we had to make some assumptions there. Whenever we need to find the mean or the standard deviation of a normal distribution, we need to make this standardization to be able to change it in terms of this new system whereby the mean is 0 and the standard deviation is 1, and we make that little adjustment where instead of it being just y is less than 45, we instead write it as some different variable, z is less than that y value minus the mean over the standard deviation. And then that there is comparable, and we can solve it from there. Perfect. So that was good work. Let us have a look then at what comes next. So in this question here, we're told that we have a sample of 250 households, and each household was asked to complete a questionnaire about their cooking to find out what to stock in a local supermarket. So A is an event that a household regularly cooked Chinese food, and B is the event that a household regularly cooked Indian food. So here we're told that it was observed the probability of B given A is equal to 0.1 and the probability of A given B is equal to 0.2. So of these households, 50 indicated that they did not regularly cook Indian or Chinese food. And then a house is selected at random, and we want to find the probability that the household regularly cooks both Chinese and Indian food. So that means that we're being asked to find at the end here the probability of A and B. Okay, so that's our end goal for this question. But we need to think, what information do we know? What can we work out from this? All right, well, we're told that 50 people did not regularly cook Chinese or Indian food. So that's an important one too, okay? So we need to think, what would that be? So let us get started then. With the given that, so probability of A given B, that is equal to the probability of A and B over the probability of B. And in this question, we are told what that is equal to. We're told that's equal to 0.2. But we don't know anything else. So the best that we can do here really is just get a little equation for this. So we could say then that the probability of A and B is equal to 0.2 probability of B, or you could rearrange that if you wanted to and times by 5 or divide by 0.2 from both sides, and that leaves you with the probability of B is equal to 5 times the probability of A and B. So that's one thing that we know. So let's work out another little fact here. So we're also told that the probability of B given A is equal to 0.1, and we can write another similar little equation for this here, which is the probability of A and B over the probability of A. All right, so here we know that that's equal to 0.1. So just like before, we can get a couple of equalities here. And this is important because this is going to enable us to make some substitutions maybe along the way. It depends on what we need once we get carried away with this question. Okay, so the other thing that we are told is that 50 out of that 250, so 50 out of 250, which would simplify just to make 1/5, did not regularly cook Chinese or Indian food. So if we were to visualise that, what that actually looks like, because I think sometimes probability it's good to visualise things. If we had A here and B here, the probability that they didn't regularly cook it would be corresponding to the bit on this diagram of the outside. So if we want to use that number, what we can do is we can find out what this big region here is, which corresponds to the probability of A union B, and that is equal to 1 minus that pink area, which is 1 minus 1/5. So now we've got another thing that we know. We know the probability of A union B, or A or B I like to call it, which is 4/5 now. So there's a really handy equation that is always true for these events, and that is that the probability of A union B, A or B, is equal to the probability of A plus the probability of B minus the probability of A intersection B. And if you think about what we know here, we can make some substitutions basically. We could get everything here in terms of A intersection B, A and B. And we know what the probability of A union B, or A or B, is equal to. So we can make all these substitutions here. So we know that this bit, A union B, is equal to 4/5, so let's substitute that. And likewise, for, say, the probability of A, let's substitute in 10 times the probability of A and B. And for the probability of B, let's substitute in 5 times the probability of A and B. And what we're going to get here is something which just can turn into some algebra, and we can solve it. So we've got 4/5 in place of the A union B equals, And instead of probability of A, I'm going to put 10 times the probability of A intersection B plus probability of B, which is 5 times probability of A and B. And then we've still got the minus probability of A and B. And just by using some basic algebra there, we end up getting 10 plus 5 and then minus 1. So that leaves us with 14. So we've got 4/5 equals 14 probability of A and B. So now we can just divide through by that 14, and that leaves us with the probability of A and B equaling 2/35. And I like to leave my answer as a fraction in statistics unless they explicitly state to round it, because otherwise we're going to lose some of the detail when we do round it. But perfect, there we go, that was that one done. So if you're not aware of some of those key rules, particularly this one here, stick it on a flashcard and get memorising it, because it is really, really helpful. Okay, so this question here is another probability question, and here we are told that an engineering company bids for 2 projects. The estimate that the probability of winning bid A is 0.4, and the probability of winning bid B is 0.6, and the probability of winning both is 0.2. So straight away here, I'm feeling like this is going to need a Venn diagram to really help us visualise this. So here, straight away, winning both is going to relate to this intersection. So that 0.2 for the both, I'm going to put in the intersection. And then call this A and call this B. So we know that the probability of winning bid A is 0.4. So that means that whole circle of A has to add up to make 0.4. So with a bit of subtraction of that 0.2 that we already know is there, so 0.4 minus 0.2, we get 0.2, and that's going to go in that region there, 0.2. Whereas with the B, we know that the probability of winning bid B is 0.6. So in the same idea, we need to remember that that whole circle must add up to make 0.6. So 0.6 minus 0.2 is going to be equal to 0.4. And then that would be that. Okay, so in part A, we're told to show that the probability that neither bid is won is 0.2. And neither bid being won would relate to this region here on the outside, wouldn't it? So now that we've got this Venn diagram, what we can do is we could subtract from 1, which is the whole. We could do 1 minus 0.2 minus 0.2 minus 0.4, and that would leave you with that shaded pink region there. And that leaves you with an answer equal to 0.2. Okay, so that's just one method that we can do. You know, a different method that we could do is use an equation that we did also use in question 5, and that stated that the probability of A union B is equal to probability of A plus probability of B minus the probability of A and B. And so we could have said probability of A is 0.4, probability of B is 0.6, and subtracting the intersection of minus and 0.2, that leaves us with 0.8. And to get the pink region, which is actually the probability of it not being A union not B, is going to be 1 minus the probability of A union B, and that is where 1 minus 0.8, we can still get 0.2, okay? So different ways to do it, but we get the same outcome, and they're both just as good as the other. Okay, so for B, find the probability that exactly one bid is won. So in this case here, we need to have a look at it and think, what is the probability that we just win one bid? So here I would say it would be the probability of A and not B, and also the probability of it being B and not A. So the probability of it being A and not B is just that region 0.2. So we're going to have 0.2 plus, and then likewise for the B and not A, that is just going to correlate to the region which is 0.4. So here I would just say it's 0.2 plus 0.4, which gives us 0.6. So given that bid A is lost, find the probability of winning bid B. So here, what that's asking us to do, if we put that into maths language, is the probability of B given that it is not A. So we need to remember what that would become in terms of this. So if we go back to that given that equation that we are sort of given in an exam, we could say then that the probability of it being B and not A over the probability of it not being A. Okay, that would be what that translates to. So we need to think, what would be the probability of it being B and not A? Well, we've already sort of mentioned that, haven't we, in the previous question? We said that that was 0.4. And the probability of it not being A is just equal to the probability, well, 1 minus the probability of A. So here we would get 1 minus the probability of A, we know is 0.4. So the probability of it not being A is 0.6. So here we end up, the probability of it being B, given that it is not A, being 0.4 over 0.6, which we can, of course, simplify down. And we can put it into our calculator, or maybe we could just see it. It ends up giving us 2/3. And again, I would avoid putting that into a calculator and then rounding it. I would put it into the calculator, get that as a fraction, and then be like, great, that is it. Don't press the SD button, leave it as an exact fraction, unless it says otherwise. Perfect though, so that's that. Let's have a look at the next question. Okay, so this question here is a projectiles question. So we're told that points A and B lie 60 metres apart on horizontal ground. And that idea of horizontal is really important in a projectiles question because everything we need to think of in terms of horizontal and vertical directions. Okay, so at the time t equals 0, two small balls P and Q are projected in the vertical plane containing AB. Ball P is projected from A with a speed of 25 metres per second at 35 degrees to AB. And you can see that's been illustrated in this diagram. So then we know that ball Q is projected from B with a speed of U at an angle theta to BA, as shown in the diagram. So we can still illustrate this, but we haven't been given numerical values for those two. So in all likelihood, that's going to be one of our challenges in this question to find those. So we're told at time t equals 2 seconds, there's a collision. So that's a really important fact because that defines the time period at which an event happens when these balls collide. So until they collide, the balls are modelled as particles moving freely under gravity. And if they are moving under gravity, that means that their acceleration is going to be considered equal to gravity. Now, if we think about this full scenario, we know that they're moving upwards, aren't they? Which means that gravity, because it's pulling downwards, we're going to consider that to be equal to minus g, because we do need to remember to think of everything in terms of its direction. And it's natural to think if we're moving upwards to class upwards as our positive direction, and anything going in the opposite direction, like gravity pulling it down, is negative. Okay, so here we're asked to find the velocity of P at the instant before it collides with Q. Alright, so for this particular question, what I like to do is I like to kind of divide these questions into horizontal and vertical and almost do like a little table which is going to help me visualise and organise all this information. So we've got horizontal and vertical. So if I think through everything that I know, so we're just looking at P. Horizontally, I know that there is no acceleration because the only acceleration is going to be due to gravity, which is in the vertical direction. And that means in the horizontal direction, we are not going to actually use SUVAT. You could still write down all the SUVAT facts if you wanted to, but essentially all that we use in the horizontal direction is just our good old traditional speed as distance over time. So we could think, well, what is that horizontal speed? What is the distance travelled? And what is the time? We could work out those. So here as well, for the vertical, we could use SUVAT because we do have acceleration there. So the acceleration in this case, we've said is going to be equal to minus g or minus 9.8. And the time we know is equal to 2 seconds. What else do we know? We're asked to find the velocity at that instant before it collides with C. So to get that velocity, we're going to need two things. We're going to need the vertical velocity at that point and the horizontal velocity or speed at that point. And we can put those together to work out what the actual overall velocity or speed is. Because imagine horizontally it might have a certain direction and then vertically it might have a different one. And together, once you know those two facts, you could work out what that overall velocity is. So that means that in this case, we need to work out the speed it's travelling at that time horizontally at 2 seconds. And we also need to know the vertical velocity at that time. So those are our aims of the games. Now, fortunately, because there is no acceleration, once we get the horizontal velocity initially, it is just the same the whole way through. It doesn't change because there's no forces, no factors that are going to make it accelerate or decelerate horizontally. So by resolving this triangle horizontally, we want the bottom component, which is the adjacent. And so that means that the horizontal velocity at that point there is going to be 25 cos 35. And for the vertical, we know what the initial velocity is, again by resolving, because that in this case is going to be the opposite of that particular triangle. So the vertical initial velocity is 25 sine 35, but that does change because of course it is going to be decelerating due to gravity. So we know then quite a lot of things. We know what the horizontal velocity is. We know that that was 25 cos 35, but we don't know what that final velocity is yet. So we're going to have to use a bit of suvat to work this out. We could use v equals u plus 80 and substitute in what we know. So we could say v is 25 sine 35 minus 9.8 times 2. And if we put that into the calculator, I make that minus 5.260589 meters per second. And so then, we can put that onto our diagram that we sketched. We can see that the velocity is negative here. So actually we could revise this a little bit because it's not going to be going upwards. The ball is actually going to be on its way back down at that point. So let's just re-edit that just to help us visualize it. So we're still horizontally moving along at that same amount of 25 cos 35, but we're going down, we now know, at a velocity of minus 5.260589. And so that means that the final velocity after this is going to take into account both of those. So what we can do is we could draw close to that triangle, and that is going to give us the velocity. So we can see that's the hypotenuse of a right angled triangle. So we could say then that to get that final velocity, the overall velocity for this, we can do Pythagoras theorem and say v squared equals, and it's going to be the 25 cos 35 squared plus minus 5.260589 squared again. And let me put that into the calculator. You might also see this referred to as the speed, and that's correct. It also is the speed that we're calculating here, but because they specifically want velocity, if we remember that velocity has both size, which is what we're working out right now, as well as direction, it means that we will then also need to finish this off with calculating the angle at which this velocity is travelling. If it was just asking for the speed, we would do this, and then that would be good enough. So I'm now going to square root this, and I make that a velocity equal to 21.14 meters per second. So that's good. So that gives us the number, the magnitude of this velocity, but we also need to know the direction of it because direction has both of those things. So if I go back to my diagram and I'm going to label this angle here, the angle below the horizontal, as theta, okay? And in this case, the opposite is this 5.260589. I wouldn't worry about the negative in this case because if we just imagine this as a triangle, that negative certainly helps us visualise where that angle is. It's going below the horizontal, but it's not going to make any difference to it as a triangle. You can't have negative lengths on a triangle. So we've got our opposite angle there, and our adjacent therefore is going to be that 25 cos 35. Theoretically, you could also use what we just worked out, V being 21.14 as the hypotenuse, but I always think it's better to not use things we calculate in later parts of a question because it just opens up potential errors a little bit more. So we've got an opposite and an adjacent, and of course a right angle triangle. So we could use tan theta equals the opposite, 5.260589, over the adjacent, which is 25 cos 35, and that will give us tan theta. So if I put that into my calculator now, I end up getting, in this case, 0.25688, and then using inverse tan, I get an angle for theta equal to 14.41 degrees. And that there will be the angle, the direction of this velocity below the horizontal. And that is that bit done. Perfect, so 6 marks, definitely a challenging one, but let's have a look at question B, which is going to continue from what we've been doing. Okay, so for B, they want us to find the size of angle of theta and the size of angle U. Okay, so what we need to think about here, and I'm going to draw my little diagram out just so that we can look at it for reference. So we know that we had that separation equal to 60 meters. We know that P was projected at an angle of 35 degrees at 25 meters per second initially, and we know that Q was projected, and this is where those unknowns come in, at an angle of theta at a speed of u meters per second at that angle. Okay, so we were also told, weren't we, that at t equals 2 seconds, they collide. And that is a really important fact there, because that is what we're going to use to work this out. So we know that at t equals 2, they're going to basically meet each other somewhere along the way. So let's imagine they meet like here, and that's at t equals 2. Well, what we know at that point is that when time is equal to 2 seconds, the horizontal distances are going to add up to make 60 meters. So whatever, say, Q travelled horizontally, added together with whatever P travelled horizontally, must be therefore equal to 60 in total. And that's worthwhile making a note of, because we're probably going to need to use that fact somewhere here. Okay, so the other thing to know is that when they collide, they would have travelled the same vertical distance. So because they must have reached that same point in time to have collided at that point. So we also know as well that when t equals 2 seconds, the vertical distance are equal. And what we're going to do now is we're basically going to use these facts to formulate some equations that in all likelihood, whenever there's 2 unknowns in a question, probably are going to turn into simultaneous equations. So we always want to be aware that that is a tool that we have in our arsenal that we can use. Okay, so let's have a look at this first fact then, that the horizontal distances add up to make 60 meters. So horizontally, we said before, didn't we, that horizontally, because there's no acceleration, you can essentially just use our traditional speed is distance over time. And so therefore the distance is just going to be equal to speed times time. And we know, don't we, that the time is 2 seconds and the speed is going to be whatever the horizontal speed is, because we're only talking about in the horizontal direction at this point. So what we want to do is find that horizontal velocity of both bits. Okay, so if we start with the P, the horizontal velocity is going to be equal to 25 cos 35, and we're going to times that by 2, and then we're going to add that to the horizontal distance travelled by Q this time. So the horizontal velocity travelled by Q is going to be u cos theta times by 2 again, because velocity times time is equal to distance. And we know that the sum of those two equals 60. And just to clarify why we're using cos, just in case you're at all unsure, remember that here, if we were to basically close this triangle, we'd have a right angle there, and the opposite would be over here, the adjacent is down here, and the hypotenuse is here. And the adjacent and the hypotenuse are used, we know those two things, or at least we want them to be in the equation, because we want the horizontal distance to be a number that we know, or the horizontal velocity to be a number that we know to calculate this. So we need to include it in the equation. So the adjacent is something we need in the equation, and therefore that is one of our unknowns. Adjacent and hypotenuse, using your SOHCAHTOA, gives us cos. So here you can see we've got a little equation that's already come up, and in all fairness we could cancel out a factor of 2 from here, because there's a 2, and you could divide 60 by 2. So we could simplify this to make 25 cos 35 plus u cos theta equals 30. So I'm going to highlight this because this is one of our important ones. So for the next fact, they tell us that the vertical distances are equal. Now, each of those vertical distances, we're going to need to use, again, a bit of trigonometry, but because we're talking vertically here, and the fact that we have a vertical acceleration due to gravity, that means we can use PhET in this case. So we want to lay out a little PhET thing for each of these. And we need to know about the distance. The distance is our unknown in these cases. So if we did one for P and one for Q, a little PhET layout. So we know in both cases that the acceleration is going to be equal to minus g. We know that the initial velocity we can work out by resolving these triangles, and we want in this case the opposite of those triangles, and so because we want the opposite we're going to use sine. So for P that is going to give us 25 sine 35. For Q it's going to give us u sine theta. We know the time because we know that this collision happens at 2 seconds, and that is all that we know. And so the equation that I would suggest that we use in this case is going to be s equals ut plus a half at squared. And we know that the vertical distances are equal, so we're going to basically say that the s for P is equal to the s for Q. So let us do a little calculation there then. So ut, so we're going to have 25 sine 35 times 2 minus a half g times 2 squared equals u sine theta times 2 minus a half g times 2 squared. Alright, so that is what that there becomes. Now, in both of those, they both have minus a half g 2 squared on both sides, which means that actually they're going to cancel out. You can imagine if we added, say, a half g times 2 squared onto both sides, it would just vanish. So that we can actually eliminate because it's the same on both, so we don't need to state it. So that then simplifies down to something much simpler than it might have originally looked. It simplifies down to 25 sine 35 times 2 equals u sine theta times 2, which actually we could cancel again. We can say that there's this factor of 2 in each, so times 2, cancel those out, and then we end up getting that u sine theta is actually just equal to 25 sine 35, which now you can see that we're really starting to make some progress. And even if you can never see the end goal with these, if you can just chip away and write down some equations, then you're going to get some marks. Okay, so here we have got u sine theta and we've got u cos theta. I would suggest here perhaps rearranging to get u as the subject in one of these, and probably in that last equation we just found it's going to be the easiest to do because we could just divide through by sine theta. So using this last equation we just got, I'm going to rearrange to get u, and in that case I get 25 sine 35 divided by sine theta. And then I'm going to substitute that into the first equation that I got. So I'm going to substitute that into 25 cos 35, and then it's plus u cos theta. So in place of the u, I'm going to replace it with 25 sine 35 over sine theta times by cos theta equals 30. So a little bit of rearranging of this is going to give us something that we can really simplify down, because cos theta over sine theta, you may recall, is equal to cot theta, or 1 over tan theta, maybe we'd prefer to think of that as in this case. So we can rearrange this to get 25 cos 35 plus 25 sine 35 over tan theta equals 30. So now we're getting there with this, and I would rearrange this now to get the tan theta on its own. So I would probably subtract the 25 cos 35 from the 30. So there we will get 25 sine 35 over tan theta equals, and that's going to give us 30 minus 25 cos 35. So I'm just going to tap that into my calculator. So that gives me 9.5212. I would then rearrange that to get tan theta, and that will leave me then with tan theta equals 25 sine 35 over 9.5212. So tapping that into the calculator, I get tan theta is equal to 1.5, and so theta, if I do inverse tan of that, I get 56.4, and that is an angle, so I'll put degrees there. And then to find u, I would go back to this equation that we've got right here, and I know that u is equal to 25 sine 35 over sine of that theta that we just found. So substituting that in, so I'm going to say 25 sine 35 divided by sine of that 56.4. I would just use the answer button on my calculator to make sure it's really accurate, and I end up getting there that u is equal to 17.2 meters per second, and that there gives us our 2 bits that we actually wanted to find in this question. So I now have our solutions. Excellent. Okay, so for part C now, we want to state one limitation of the model other than air resistance that could affect the accuracy of our results. So here we could talk about a range of things. We could talk about the fact that there might be a different size of the ball or spin of the ball, and those things might affect it. You know, not every ball has the same size, same texture. Even if you think of a golf ball, for example, all of these things could affect it. So we'll just say something like not taking account of the size of the ball, or ball size. Perfect, so that's really, really good. So that is that question. Let's have a look now at the next one. Okay, so this question here is a relatively simple one, really. We're given a couple of forces and we want to find the magnitude of the resultant force of the particle. Now, whenever we want to find the resultant force in maths, I would recommend that we try and organise ourselves so that we have all of the horizontal forces, all of the vertical forces, and then put them together into a little right-angled triangle. So basically we get the sum of horizontal forces. And this works for velocities too. Any vector quantity, we'd get like the sum of all of the vertical forces, and then we could work out the magnitude of the resultant force by using Pythagoras' theorem using those. So that is magnitude of resultant. And we're going to do that by using just a bit of Pythagoras' theorem. So in this case here, obviously we have got already a horizontal force here, just 7 newtons. That is one of our horizontal ones. But we're going to have another horizontal one too, because if we think of that 3 newtons, which is shooting up at 30 degrees from the horizontal, that we can resolve into both a horizontal and a vertical component. Okay, so for the horizontal component, we will need to use a bit of trigonometry. So I'm going to draw that triangle out here again. So that 3 newton, and I know that it has got this 30 degrees to the horizontal, so I can work out the horizontal component, and I can also work out the vertical component just by using a little bit of trigonometry. So this component along the bottom here, this refers to the adjacent, and the hypotenuse is up here. In this case then, we're going to use cos because we've got the adjacent and the hypotenuse, and so that horizontal component is going to be 3 cos 30, whereas the vertical component is going to be 3 sine 30. So when we go back to this then and we think of what we said, so the sum of the horizontal forces is going to be that 7 plus 3 cos 30, and the sum of the vertical forces, well, there's only actually one, is going to be just 3 sine 30. And so if we tally those up, I make 7 plus 3 cos 30 equal to about 9.598 if we round it to 3 decimal places. Whereas for the vertical component, I just get 1.5. And then, like we said, to be able to then find the magnitude of the resultant, we have to use Pythagoras' theorem to get that hypotenuse of this right-angled triangle. So the resultant magnitude is going to equal the square root of 1.5 squared plus 9.598 squared. And if we pop that into the calculator, I make that 9.71450 newtons. They haven't said to round it to a specific amount, so round it to a sensible extent and then just state that you've rounded it to, say, 2 decimal places. Perfect, really good. So in part B then, they want us to find the angle between the resultant force and that force at 7 newtons, which means if we sort of return back to our original little diagram, they want us to find this angle here, because 7 newtons is actually just the horizontal line, isn't it? So all they're really asking for us here is the angle between the resultant force and the horizontal. So we need to find theta. So here you can see that we know in that right angle triangle, we know the opposite of it and we know the adjacent of it. We've already sort of done all of our labelling. So therefore we can say then that tan theta, as we know it is opposite over adjacent, we can say that tan theta equals 1.5 over 9.598. And then we will get then that theta is equal to tan to the minus 1 of that. And I end up making that theta equals 8.882 degrees if again we go to those 3 decimal places. So just round to a sensible amount. They haven't specified what they wanted you to round to here, so long as you round correctly and sensibly, you should be absolutely fine. So perfect there. So we have got our solutions to that question. You can see that trigonometry and Pythagoras' theorem come up really quite a lot in mechanics, so we always need to keep our eyes out for it. That's good. Let's have a look then at the next question. Okay, so here what we have is a pulleys question. And so in this pulleys question, we need to really think about the forces at play here and also what direction this is going to move, if it's going to move at all or if it's just being held in place. All these things are things we need to think about. So I would recommend that we really label the diagram given, or we make our own sketch and label it really fully. This is the thing about mechanics, you need to have labelled diagrams. So I will probably draw my own. I would normally do this just so that I can make it as big as I want and just have it free to sketch on, and I will still have the original one there for me to refer back to should I want to without my scribbles all over it. So I've got B is here, I have got A is here, and what I would do is I would read through the text and label it as I go. So on one end of a light inextensible string is attached to a particle of mass m, so that is A, so I'm going to do a downwards arrow that is labelled mg, because that is the force associated with the mass of m. So the other end of the string is attached to a second particle b of mass lambda m. So I'm going to do a downwards arrow at b and I'm going to label that lambda mg. So particle A is in contact with a rough plane inclined at 60 degrees to the horizontal, and it is a rough plane. That is important, because that means that there is going to be a frictional force. So the string is taut and passes over a smooth, small pulley at the top of the plane. The part of the string from A to P is parallel to a line of greater slope of the plane, and P hangs freely below P. The coefficient of friction between A and the plane is lambda, and this is what I was waiting for with that friction. I didn't draw it straight on because I wanted to check what direction A is about to move, because you'll find in these questions that sometimes they will change it mid-question, or it will be just not what you expected. So A is on the point of moving down the plane. If it's about to move down the plane, then that means that the friction always opposes the motion. So that actually means in this case that the friction is going to be acting up the plane. So really, really important, because if I hadn't read that, I certainly would have written the friction going downwards because it just seems more natural that way. But of course it does depend on which of these masses is bigger, and we don't know at this point. So the other final thing to label on our diagram are the tensions associated with this string. So I've got tension, and they always oppose the pull of the mass. So they're always going to be pointing towards the pulley. All right then, so we've got our nicely labelled diagram. Actually, there's one other force finally to do, and that is the reaction force at A, because A is sat on a surface, so we don't want to forget that there is also a reaction force. We'll label that R. And the real importance of that reaction force, which goes perpendicular to the surface, is that the frictional force is equal to mu R. And so in this question, if they told us what the coefficient of friction was, we could use that to work it out. And in this question, we're asked to find this coefficient of friction. It says find the exact value of mu when lambda equals 1/3. So if that was the case, instead of writing lambda mg, we could have written 1/3 mg. And here we're being asked to find out what that mu is. So what I would do in this case is I would resolve our forces. I would first work out, say, what the reaction forces are. Because if we know what R is, we can then sort of write a formula for friction as well. So R in this case is perpendicular to the plane. Now there's no movement perpendicular to the plane. It may well slip and slide up and down the plane, but not perpendicular to it. So that means that the forces are balanced there, which means that this reaction force is going to be balanced with that particular component there of the weight of A. So we could say that R is equal to mg cos 60. Again, that is just using our SOHCAHTOA to work that out. One really, really common mistake I find people do with the slopes is they close that triangle that I just drew there incorrectly. But what you always want to do is always imagine that you're closing the triangle with lines which are either parallel to the plane or perpendicular to the plane. Okay, don't do any angles, any like little lines jutting off here, sort of horizontal or vertical. No, the question becomes entirely about the direction with respect to the plane when we're doing this. Is it perpendicular or parallel to the plane? Okay, so we've got a reaction force here. So now let's do some resolving, okay? So with these particular questions, I would recommend that you completely visualise the situation that A is under as separate to the situation B is under. So if we start by looking at A, let's resolve the forces there. So we know that it is at the point of moving down the plane, but it isn't moving down the plane. So there's no acceleration, the forces are still balanced. So that means that the upwards forces are going to be equal to downwards forces. Acting on A, we can say that we've got two forces acting upwards, and we've got this one force, this component of the weight, acting downwards. So therefore, we could say that the friction plus the tension, they're our sort of up the plane forces, is equal to our down the plane forces, which in this case is going to be mg sine 60 when we resolve that angle. Okay. So the frictional force, we know, because of our little equation here, we know that is equal to mu r. So in that case, I would replace friction with mu r, and of course we know what r is. So I would replace it with mu times by what we know r to be, which is mg cos 60. You may be thinking, like, why don't we put g in as a number? Why don't we put the sine 60 and the cos 60 in as a number? And we could, but I fear we would just lose detail as we go. And here, especially as we're asked to find the exact value, that's where the problems will start to pop up, because if we put like 9.8 in a calculator and things like that, we may well cause issues for ourselves. And just wait and see, you're going to see some magic happen. So that is probably as far as we can go there. So now if we look at little scenario B, which again, let's just imagine that we're in a little world of our own. We're just looking at B for a moment now. So for B, it looks quite simple. For B, we can see that there's only two forces acting. Now, if we think here about what's happening, again, we know that in this case, it's not moving, it's balanced, it's at the point of moving down the plane, but actually nothing's actually going to happen. So in that respect, we could again say the forces are balanced. So we could say that T is equal to 1/3 mg, because remember lambda in this case, for this particular question in part A, is equal to 1/3. So now we know that T is equal to 1/3 mg. Now this is something that we can substitute back in to our previous equation. So let's do that. So by substituting that in, we end up with mu mg cos 60 plus 1/3 mg equals mg sine 60. And this is where the magic that I mentioned comes in, because all three of these terms have an mg in them. So they're actually just going to cancel out. And now we've got something significantly simpler here. We have got mu cos 60 plus 1/3 equals sine 60. And this is now something where we can start to put numbers in. Now sine 60 and cos 60 give us exact values when we enter those into our calculator. Sine 60 is √3/2, cos 60 is just a half. So here we have mu times a half plus 1/3 equals √3/2. So rearranging this, we will get a half mu equals √3/2 minus 1/3, and then to get rid of that factor of a half, if we just double everything, we get √3 minus 2/3. And that there is the exact value of mu when lambda equals 1/3. Okay, so in the next question, we're told to show that the value of lambda must be less than the root 3 over 2. So let's have a think of this one then. So if we here return to some of our workings from previously, so we know that we had resolved the forces on this, and we knew, quick rough diagram here, just a quick rough diagram, just a little recap. So we know that when we resolved our forces for the A scenario and for the B scenario, we had a good idea of what was going on. So for A, we think of our original working, we said that the component of the weight of A that was acting down the slope, so mg sine 60, was equal to the tension plus friction. And for B, we also knew that because this isn't moving, it's just at the point of moving up, but it's not actually moving, we knew that the forces were balanced, and we said that T was equal to lambda mg. Now, of course, in part A, we had a value for lambda. We said lambda was a third. But if we step back and instead of having an actual number, we just keep it as lambda, we'll be able to solve this question. So in that case then, if we make a little substitution, we could say that by putting tension in to the first equation, we could say mg sine 60 equals lambda mg plus the friction. So if we there try and get friction on its own, and we make a little substitution there in place of sine 60, because the exact value for sine 60 is root 3 over 2, we end up getting root 3 over 2 mg minus lambda mg. And we know, because this is a rough surface, that friction exists. So we can say that that is equal, what? Bigger than 0. So in that case then, because we know that friction has to be bigger than 0, if we take what we have there and kind of just rearrange it, we will get our solution. So root 3 over 2 mg minus lambda mg is bigger than 0. By rearranging that then, we end up getting lambda mg is less than root 3 over 2 mg, and the mg's will cancel, and you will get exactly what we need to get for this question. That lambda is less than root 3 over 2. Perfect, so I hope that made sense. So it was really just going back to almost our working from part A, and then just understanding that because this is a rough surface, friction has to be bigger than 0, and making that substitution. Okay, so part C, A is now moving up the plane. Okay, so that is the really important bit here. So in that case, we now have basically a different scenario. And this is where drawing your own triangle can be good, because imagine if we were still just scribbling on that first one that had been given to us, it would be looking quite a mess by this point. And we don't really want that. Now the tension's still going to be acting in the same way. The weight is still going to be doing the same thing. B, they have told us that lambda equals 3. So instead of writing lambda mg, we can write 3 mg. And then the friction now, because A is moving up the plane, remember friction always opposes the motion, so friction is going to be acting downwards. So in this case, we are told that lambda equals 3 and the acceleration of A is a half g. So it is moving up the plane now. That means that rather than the upwards equaling the downwards, etc., that isn't the case. Now we're going to properly use F equals ma. And if A is moving up the plane, then B is going to be moving downwards. So in order to solve this one now, what we will need to do is to again think of our A and our B as our own separate little bubbles and write some nice equations for that. So for A, we know it is moving up the plane. So that means that when we do F equals ma, the resultant force has to be acting upwards. So in that way, we need to think of what forces we have at play here. So we've got the tension moving it upwards. I always like to imagine I've got like an imaginary dotted line dividing the upwards versus the downwards. I'm going to have the component of the weight acting down, and I'm also going to have the friction acting down. So I've got the tension, and then resisting that, I have got the perpendicular to the plane component of the weight, which is going to be mg sine 60, and then I'm also going to subtract the friction, and that will be equal to ma. So the friction, of course, is equal to mu r, and mu r, well, we're not told what mu is. Again, we need to find mu, but we certainly can work out what r is, because r is the force acting upwards perpendicular to the plane, and that is equal to, because it's not moving sort of in that plane or perpendicular to the plane, it's moving parallel to the plane. That means then that r is going to be equal to the perpendicular to the plane component of the weight, which means that r is going to be equal to mg cos 60. So we could say then that the frictional force, not to be confused with the F equals ma, the frictional force is equal to mu mg cos 60, which we could substitute back into this. So we've got T minus mg sine 60 minus mu mg cos 60 equals ma. Okay, so I know this seems like a lot of work, but just bear with me, this is going to work. All right, so let's have a little look then at the next bit. All right, so let's have a look then at B. Let's have a look at the little bubble for B. So let's have a go writing it over here then. So for B, for its little bubble, we know it's moving downwards, because if A is moving upwards, that must mean that B is moving downwards. Again, we're going to use F equals ma, where F is the resultant force. Now, if it's moving downwards, that must mean that the weight is bigger than the tension. So Fmg minus the tension, which is opposing its direction, is equal to ma. And when we say ma in this case, we need to remember, well, what is the mass of B? The mass of B is 3m. It didn't matter when we did A, because the mass of A was just m, so m was just m. But in this case, we do need to be careful of that. So we've got 3mg minus t equals 3ma. Now, one extra little thing that we can add to both of these equations that we have just done is, of course, we know what A is, don't we? We're told in the question that the acceleration of them is a half g. So we can fill that in as well. 3mg minus the tension is equal to 3m times a half g, which ends up giving us 3 over 2 mg. And so if I go back to the other one as well, just to fill this in, I've got t minus mg sine 60 minus mu mg cos 60 equals m times a, which is m times a half g. So we could write a half mg there. So looking good, we are getting close now. Now, with what we just worked out for B, because everything is now in terms of mg, we can actually do a little bit of rearranging to get t as the subject. We could say that t would be equal to 3mg minus 3 over 2mg. So we could say that the tension is equal to 3 over 2mg, because that's how that will cancel out. And now that we know that, we can substitute that back into the equation that we had for A. Because, of course, if I sort of highlight just to show you, if tension is 3 over 2mg, we can substitute that right in there. So putting those together now. So instead of t, I'm going to write 3 over 2mg, and I'm going to rewrite the rest of basically our equation for A. And if I look at that, I will notice that every single one of these terms has an mg, so I can cancel each of those out. Mg's are all going to go away. And I get left with something much, much simpler. Now, I would also think, okay, I know that sine 60 and cos 60 have exact values. This is why they drilled that into us at GCSE. So I would replace those now with it, so that what I just have are some nice clean numbers. So sine 60 I know is root 3 over 2. I know that cos 60 is a half. And now I've got something I can just rearrange. So all of these have factors of a half, so I would just multiply everything by 2 to start off with, so that I'm not dealing with any more fractions, because no one likes fractions. So now I would try and get the mu on its own, and I would probably move that, add it to both sides so that I get a positive value for mu, and then I would subtract the 1, and that leaves me then with mu equals 2 minus root 3, and we are done with that question then. We have our solution. Again, we've got an exact value, and the way that's worked out, we can be quite confident that that's right then, because we did get an exact value. So that's really good. Let us try now our next question. So for this question here, just like most mechanics questions, to be honest, I would really recommend that we draw a labelled forces diagram so that we can really see what's happening. So reading through this question, we can see that we have a box of mass 15 kilogram is pulled in a straight line along a rough horizontal floor. Now the fact it's rough is important because we know then that it is going to have friction, which it doesn't always have. If it was a smooth floor, then it wouldn't have that. They tell us the angle at which the handle is inclined to the floor. They don't give it as an actual angle though, they just say that tan alpha equals 3/4. They tell us the tension in the handle. They tell us the coefficient of friction between the crate and the floor. And they ask us to find the acceleration of the crate. Because it's not in equilibrium, it's not stationary. In this case, they are pulling it, aren't they? So first things first, let us draw a nice labelled diagram. Okay, so I've got my 15 kilogram mass. It is still being pulled with a tension equal to 50 newtons, so I'm making sure I include that. We also know though that there is a frictional force, and we know that friction opposes motion. So because it's being pulled over to the right, the frictional force we're going to draw acting to the left. Now, as well as that, we're going to have the weight, and weight is always mg. So we know the mass is 15, so it's going to be 15g. I wouldn't worry about putting that into a calculator. It is really helpful to leave it in terms of g quite often in mechanics. And then finally, the last force to include is the reaction force, R, okay? Now, I'm going to add in an extra little fact here that we're going to need to know to use this. And that is that the frictional force is equal to mu, the coefficient of friction, times by the reaction force. So once, if we can work out what the reaction force is, then because we know that the coefficient of friction in this example is equal to 0.15, we will then in turn be able to work out what the frictional force is. So let's have a look at what else we've been told. We know that alpha is the angle that the handle is being held at, but we're not told the actual angle. And your first instinct might be, oh, if I know that tan alpha is 3/4, let's get our calculator out and do inverse tan to work out what alpha is. I would not recommend this. We want to keep it as an exact value for these ratios when we can. What I would recommend you do is you mock up a little triangle, a little right angled triangle, and you remember your SOHCAHTOA. So remember that tan is equal to the opposite over the adjacent, isn't it? And if we remember and equate it to the 3/4, we could say that the opposite side in this case would be 3 and the adjacent would be 4. And then we've labelled the sides on a right angled triangle. We can now work out what the final side is just by using a bit of good old Pythagoras' theorem, to be honest, which is the square root of the sum of the squares of the other two sides. So we get 5 for the hypotenuse in this particular triangle. And you're probably thinking, but why are we doing this? But the reason being is we could then work out what sine alpha is equal to and also what cos alpha is equal to without ever actually having to use your calculator, to be honest, without having to use sine or cos or work out that angle, because we can just say, using SOHCAHTOA, that sine is the opposite over the hypotenuse, so that is now 3/5, and cos alpha is equal to the adjacent over the hypotenuse, so that is equal to 5/5. And that is something now that we can make some substitutions with when it comes to actually getting down to it with this question. So we've done a lot of laying the foundation with this, but that is how I would recommend you treat these mechanics questions. Get all of your information on paper, get everything labelled so that then you can go forwards with it. Okay, so here we have some forces and a box that is accelerating. So I'm going to suggest we use F equals ma. Now we know it is moving to the right. Now, if we were then to think about, is it moving up or down though? We would say, well, no. If we were going to look at it in the upwards direction, or like in the vertical direction, we would say that the resultant force is actually equal to 0 because it is balanced, the up equals the down. So in that case, we could say, okay, so the resultant force is equal to 0. Or you could say that the up is equal to the down. So if we look at what forces there are in that up and down, and we'll go back to our little diagram to see it, we have a reaction force that is acting up. We also have a component of this tension acting up, and then those are all the acting up ones. And then in terms of acting down, we only have one force. We have the weight. So what I would do here for the vertical direction is I'm going to say, okay, what is the upwards force? So I can see the upwards force is R plus, like we said, a component of the tension. We're not going to say 50 because not all of that 50 newtons is acting upwards. We're going to need to use a bit of trigonometry. And because that is the opposite side of that triangle, and we already know the hypotenuse being that 50, we're going to use sine. So that side there is actually equal to 50 sine alpha. So when we go back to resolving, so those upwards forces are equal to R plus 50 sine alpha, and that is equal to the downwards force, which is just 15g. And we can start to use some of these facts that we know, because we know that sine alpha is just equal to 3/5. So we can just make a little substitution there, and this is going to start to come together, because we can say R plus 50 times 3/5, and 50 times 3/5 is actually just equal to 30, is equal to 15g. Well, now you can see that if we rearrange this, we could work out what R is, couldn't we? Or maybe we'll just leave it in algebra form, so 15g minus 30. But we could certainly now put that into a calculator and actually get a number for that. So I'm going to do that now. I'm going to tap that into a calculator and see what we get. So I get there quite a nice round number actually. I get an answer for R equal to 117 newtons. So that is going to be important, because now that we know that, remember we said that the friction was equal to mu times R. So let's work out what the frictional force is then. So that is going to be 0.15 times by 117. So we get the frictional force is equal to 17.55 newtons. Okay, so that there is going to be the next really important bit. So by resolving in the vertical direction, what we did was we were able to work out what the reaction force was equal to, and then we were also able to use that to work out what the frictional force was equal to. So now most of these unknowns in this scenario we actually know. There's one last thing we need though. So if we resolve horizontally now, we know it is actually moving and accelerating to the right. Okay, so here it isn't a case of the left equals the right, it's not balanced. In this case we are going to say F equals ma. And so for that F, we need to say, well, what is that resultant force? So the resultant force is going to be this force acting forwards, subtracting this force here, the friction, which is acting backwards. So for the forwards force, again, that is coming from the tension. So again, we're going to need to resolve it. And because this side here that I have selected, this purple side, is the adjacent in that triangle that we've got here, we are going to say it's cos, 50 cos alpha. And a little trick that I think one of my students told me in the past, a really silly trick that you'll probably think is just so silly, is that this side in this case that we were looking at here is the side that's cozy to the angle. It's the one right next to the angle. It's all cozy to it and snug next to it, and that's why it's cos. And you know, when I first heard it, I thought, oh, that's a bit silly, just do SOHCAHTOA. But do you know what? I do it in my head all the time now too, because it's just quicker. Because this pattern, we always know with this resolving, it's going to end up being sine or cos. So if we can come up with a quick prompt, great. I'm going to live with that and I'm going to take it, because it's all about finding nice quick ways to do things. So that resultant force, F, is going to be the forwards force minus the backwards force basically, and that's going to equal ma. And the forwards force in this case we've just said is going to be 50 cos alpha, and then minus the backwards force, which is the friction, which we've just said was 17.55, and that's equal to ma, m being 15 and a being the acceleration that we are going to find. And cos alpha, don't forget that we said that cos alpha was equal to 4/5, so we're going to make that substitution here. So 50 times 4/5 is going to just be equal to 40. So we've got 40 minus 17.55 equals 15a. And so time again to tap that away into the calculator and see what we get. So I make that 22.45 equals 15a. And then if I divide through by that 15, I get a number which will round nicely to two significant figures to 1.50 meters per second squared. And that is our answer. That is our acceleration. So I hope that made sense. I don't think that was the worst question in the world. I think that was all right. We just used our F equals ma. We remembered that if something is accelerating, then we don't have balanced forces, basically. We can't say that the left equals the right and the up equals the down. Instead, we have to properly say F equals ma. All right then, that is great though. Let's try part B of this question. So we're told that the crate is now pushed along the same floor using the handle. So we're pushing now instead of pulling, and the thrust in the handle is still 50 newtons again. So explain briefly why the acceleration of the crate would now be less than the acceleration of the crate found previously. So basically this particular scenario, how we're pushing that instead of pulling it, is going to increase the reaction force. If you notice, it's almost like it's pushing down on it rather than pulling it up like it was in the last case. It's almost pushing it down. So as a result, what we're going to get here is we're going to increase R, the reaction force, and which in turn is going to increase the friction. Because of that F equals ma, increasing the friction is going to decrease the resultant force, which in turn will decrease the acceleration. So that's what we want to think about there. Because they are, of course, proportional, aren't they? Because we know that F equals ma. So if that F goes down, then the acceleration also goes down. Perfect though. So that was really good, really, really good. So I hope that that was clear and that made a good bit of sense. With those wordy ones, just think through what changes and then you should be able to come up with an explanation. Okay, let's try out the next question. So this question here, we are told that we've got a parachutist jumping out of the aeroplane and we're given an expression for its velocity. So an equation for its velocity, which is a vector. So you can see that there is an I component and there is a J component. Now, I think it's important that we remember, physically speaking, what that I and J component are referring to. You know, it is telling us that the velocity has a certain amount acting, in this case, to the right because it's positive. And then it also has a component acting downwards, okay, because this component, obviously he's a parachutist, he's not going to be flying up into the sky. Also, if we were to type this value, 60 e to the minus 0.25t minus 1 into the calculator, we will see that that is actually a negative value. Okay, so these are the components, both horizontally and vertically, of what is happening here. So it says assume that the parachutist is at the origin when t equals 0. We want to find an expression for the position vector of the parachutist at time t. Now, what I always like to do in the beginning of these questions, and this is a variable acceleration question, is just to make a note of S, V, A, where S is displacement, V is velocity and A is acceleration, and just remind myself how I can go from one to the other. So I know if I differentiate displacement, I get velocity, and if I differentiate velocity, I get acceleration, and then likewise, if I do the opposite and I integrate acceleration, I end up with the velocity, and if I integrate velocity, I end up with the displacement. Okay, so here what we're going to have, as we've been given the velocity and we want to find an expression for the position vector. Position vector is all about the location or the distance of it, the displacement of it. So we need to find S and we have been given V. So that means that we need to integrate what we're given to get what S is. Or when we're talking about vectors and position vectors, we often use an R, and that R is often an R with a line as well to denote that it is a vector. But you might see it written in bold instead. Okay, so let us have a look then. So that R is going to be equal to the integral of 50 e to the minus 0.25 t I, and the integral of that 60 e to the minus 0.25 t minus 1 j. And that's all with respect to t. Now, here for this first one, don't forget that whenever we want to integrate an exponential, so if we had, say, y equals e to the kx, the integral of that is equal to 1 over k e to the kx. So we're going to use that throughout here ourselves. So in this first case here, we're going to take that 50 and divide it by minus 0.25 and then e to the minus 0.25t. And that is going to be our I component. Don't forget with integration, we always add on a c as well. So we're going to do plus c here. And that is our I component. And then over here, I would probably recommend that we multiply out the brackets here before we actually get to integrating. So this is 60 e to the minus 0.25t minus 60. So what that becomes is going to be 60 divided by minus 0.25 e to the minus 0.25t and then minus 60t. And then, of course, don't forget, don't want to close those brackets too early, you can do a plus c as well, and that is the j component. Now here, because we have two plus c's, what I would recommend you do is you label those differently, because they are different, they came from different integrals. So the first one you could call like c1, second one c2, or you could call the first one c, the second one d, whatever, so long as you know that they are different and you're not going to treat them algebraically like they are actually the same thing. Okay, so if we have a look at the question, we're not quite done yet. We're missing a little bit of information because we need to know what those constants are. So we could simplify a touch now and just tidy this up a bit, but then we need to have a look for how we could work out what C and what D actually are. So that will be our next little thing. So have a little look through the text in this question to see if you can find anything that is going to give us that little hint. So the thing, in my opinion, that is the most powerful bit that is going to help us answer this is the fact that the parachutist is just at the origin when t equals 0. So because we're talking about displacement here, this thing that we've just found is the displacement. If something is at the origin, then that means it is essentially at 0, 0. So when it says here that it is at the origin, its displacement, the vector r, is equal to 0i plus 0j. So what that enables us to do then is to take each component of this, so say we'll take the I component and we can now equate it to 0. We can equate it to the 0 that we know it is at the origin. So if we substitute in t equals 0, so if we say when t equals 0, it is 0i. So we could say, okay, minus 200 e to the 0 plus c is equal to 0. And e to the 0, of course, just becomes 1, doesn't it? So really what we have there is that minus 200 plus c equals 0. So c will equal 200 if we rearrange that. So see there, we have now found one of those constants and we have nearly completed this bit. So we're going to do exactly the same. I'll use a different colour pen just for clarity for the other bit. So again, when t is equal to 0, we know that we have 0j. So we're going to make that substitution in here. We're going to get minus 240 e to the 0 minus 60 times 0 plus d, and that is all equal to 0. So e to the 0 again just equals 1, and 60 times 0 becomes 0. So here, if we rearrange this, we'll end up getting that d is equal to 240. So just like before, we have now got the value of this other constant. And all just using that fact that we know that at t equals 0, the displacement is 0. The position vector is at the origin. So find an expression for the position vector of the parachutist at time t. We are just going to say there that r is equal to, and then we go to what we have in the earlier line, but we're just going to include within that our constant. Okay, so we have got minus 200 e to the minus 0.25t plus 200 I, and then plus, and I'm going to have to do this on the next line, not enough space, minus 240 e to the minus 0.25t minus 60t plus 240, and that is the j component. You could of course do some factorising there, but it's all going to have the same outcome. They haven't said it had to be written in a certain specific way, so we are happy with how that looks. And that is it, okay? So the main thing there, if you're not 100% aware of this relationship with variable acceleration between displacement, velocity and acceleration, and how you can go from one to the other, make sure you learn that. And also just keep an eye out for times when you can equate I and j components to specific things, like in this case, when we knew that it had zero displacement at that point. Okay, so that's really good then. So let's have a look at the next question. Okay, so we're still in the same example, and we're told that the parachutist opens their parachute when they have travelled 150 metres horizontally. And we're asked to find the vertical displacement of the parachutist from the origin when the parachute is opened. Okay, so here if we think about what we've been told, we have been told the horizontal displacement when this event happens. We're told that that's equal to 150 metres, but we're not told the time, okay? So this is just at t equals t, basically. It's just at this unknown time. And we're being asked to find what that vertical displacement is. That's our question mark in this case. So the thing to realise here is what we have just found in part A was a formula for displacement, okay? We had that formula for displacement. We said that R was equal to minus 200 e to the minus 0.25t plus 200 I plus minus 240 e to the minus 0.25t. Oh, hopefully the last time we're going to have to write this out. It's a long one. Plus 240 j. Okay. So here this is important because essentially what we now know is that the horizontal displacement is 150. So what that means, because I of course refers to the horizontal displacement, means that we can equate this minus 200 e to the minus 0.25t plus 200. We can equate that actually to 150. And that means we can rearrange this to find out what t is. And once we know what t is, we can work out what the vertical displacement is. So here, if we rearrange this, let's subtract 200 from both sides. We get minus 200 e to the minus 0.25 t equals minus 50, cancelling out a minus from each side and dividing through by 200 leaves us with e to the minus 0.25 t equals 1/4. And next I would take lns of both sides to get rid of that e. And then finally, to get the t on its own, I would either divide by minus 0.25 or I would multiply through by minus 4. It looks a bit more elegant, so I'm going to go with that. And here then, if we tap this away into our calculator, we find that t is equal to 5.54518. So see there, we now have a time, all right? And that's really important, so I'm going to highlight that because that is the time at which that particular horizontal displacement is found, and that is the time that we can now substitute into our vertical part, because remember the vertical bit is what we're trying to find. So I guess we would finish up here then by tapping that away into our equation. I would suggest maybe we don't literally write everything in. Let's do it. Let's overcome the pain. Let's write all this in. 518 minus 60 times 5.54518 and then plus 240. See, we did it, we got there. Okay, so that is everything there. Substitute into that vertical component at that specific value of t. So we'll substitute that in and I end up getting a value for y equal to minus 152 and 0.711 meters, and that means that the vertical displacement is equal to 152.711 below the horizontal, so below the origin. And then that is it, okay? So really important that you understand really the relationship between the I and the j and horizontal and vertical components there. Okay, so in part C, we're told to carefully explaining the steps that you take to deduce the value of g used in the formulation of the model. So g is an acceleration, that's one thing to say, and it is an acceleration in the vertical direction, isn't it? Because g is all about the pull due to gravity towards the earth. So that is the vertical acceleration that we have here. And that's important because that's going to give us the information we need to do this. So if we go backwards a bit here, and we go back to the previous bit of the question, right at the beginning when they told us what V was equal to. And they told us that V was equal to, just as a little recap, 50 e to the minus 0.25 ti, and then plus 60 e to the minus 0.25 t minus 1 j. Okay, so we knew those two things right at the beginning of the question. And we also said, didn't we, the relationship between S, V and A. And we said that if we wanted to go from V to A, we need to differentiate V. So now, because we're talking about an acceleration, yeah, a bit indirectly, they haven't actually said the word acceleration, they wanted us to deduce that. But because we know that now, what we could do is we could take this vertical component of velocity and differentiate it, and that will give us the vertical component of acceleration. So the vertical acceleration will be what we get by differentiating what we have here. To be like differentiating with respect to time 60 e to the minus 0.25t, and I'm going to multiply out the brackets while I'm here, minus 60. Okay, so just to remind you, if we want to ever differentiate an exponential, say y equals e to the k x, then dy dx would be equal to k e to the k x. Okay, that is what we're going to use to work that out there. And so then, in this case, that vertical acceleration is going to be, if we multiply through by minus 0.25 times 60 e to the minus 0.25t minus 60 differentiated just becomes 0, doesn't it? Because it's just a constant. So here then, minus 0.25 times 60 is equal to minus 15 e to the minus 0.25t. And here then, that means that initially, in that sort of initial state when t is equal to 0, that would tell us that g is actually equal to 15. And that doesn't sound right, does it? So the value of g used in this model looks to be g equals 15, but really it should be 9.8 or maybe 10 at a push if we're rounding more. So it's not ideal, this model, but we have deduced the value of g that was used in the formulation of this model, and that was 15. Perfect. So well done getting through this paper. I think it's been really good practice, and keep at it. Just keep trying. Don't be disheartened if anything seemed hard. Just go over it again and it will soon become clear. Just practice makes perfect with maths. All right, I will speak to you soon then. Bye.
Ouch! This is why in some videos I have unexplained scratches.